Welcome to my maths class. In this class, we'll solve sums from class 10 NCERT textbook, chapter Statistics, exercise 13.1, question 1. Now, we will learn some basics of this chapter. Class interval. Class interval. This, for example, 10 to 20 is a class interval. In this, 10 is called as a lower limit. Lower limit. Lower limit is 10. It's called a lower limit. 20 is called as the upper limit of the class interval. Upper limit. Upper limit is 20. This is a class interval. 10 is called as a lower limit. 20 is called as a upper limit. Now, next is class size. Class size or class width. Class width means the gap between the lower limit and the upper limit. So, how to calculate the class size? Upper limit minus lower limit. Upper limit minus lower limit will give us the class size. So, in this case, upper limit is 20, lower limit is 10, the class size is 10. Next is class mark. Class mark. Class mark is the midpoint of the class. Class mark is the midpoint. To find the class mark, we have to lower limit plus upper limit divide by 2 will get the class mark. In this case, 10 plus 20 divided by 2. The class mark is 30 by 2. Class mark is 15. Lower limit plus upper limit divided by 2 will get the class mark. Next, the class intervals are of two types. The first type is continuous. Class intervals. Continuous class intervals. For example, 10 to 20, 20 to 30, 30 to 40, and so on. You can see here there is no gap between the class intervals. It is continuous. 10 to 20, 20 to 30, 30 to 40, and so on. It's also called as exclusive type, exclusive type, because in this type of class intervals the upper limit is not included in the class. The upper limit is excluded. You can see 20 will not come in this, 20 will come in this one. 30 will not come in this class, it will come in this class. So it is called as exclusive type. See, the upper limit is excluded. Upper limit is excluded in the class. Excluded in the class. The second type is discontinuous class intervals. Discontinuous class intervals. Here the classes are not continuous, they are broken. For example, 10 to 19, 20 to 29, 29 to 39. It is called as inclusive. Inclusive. Because in this case the upper limit is included in the same class. Upper limit is included in the same class. 19 will come in this class when it will come. 29 will come in the same class. Here in this case it was excluded. Here it is the upper limit is included. Upper limit is included in the class. Included in the class. So it is called as inclusive type. Next, now we will learn how to we will see the conversion of discontinuous class intervals to continuous class intervals. Suppose the class intervals are 10 to 19, 20 to 29, 30 to 39, 40 to 49. They are not continuous, they are discontinuous. We will see how to convert them into continuous class intervals. They are discontinuous class intervals. We will see how to convert them into continuous class intervals. For this, what you should do, from the lower limit we have to subtract 0.5. So 10 minus 0.5. We have to subtract 0.5 from the lower limit. So we will get 9.5. then we have to add 0.5 to the upper limit. 19 plus 0.5. So we will get 19.5. To convert this, we have to subtract 0.5 from the lower limit and we have to add 0.5 to the upper limit. Then we'll get the class interval. So we'll get 9.5 to 19.5. Again, from this also we have to subtract 0.5. Then we will get 19.5. We have to add 0.5 to this. We will get 29.5. Subtract 0.5 from this. 29.5. Add 0.5 to this. 39.5. Again subtract 0.5. So 39.5 to 49.5. So now it became continuous type. 9.5 to 19.5, 9.5 to 29.5, it became continuous. We will see how to find the mean of a group data. To find the mean of a group data, there are three methods. The first one is called as direct method. Direct method. This method is used when direct method is used when the values of fi and xi are small. Direct method is used when the values of fi and xi are small. The second method is assumed mean method. Assumed mean method. Assumed mean method is used when the values of fi and xi are large. There is the third method. It is called a step deviation method. Step deviation method. Step deviation method is used when there is a common factor among the values of di. The step deviation method is used when there is a common factor among the values of di. Now we will see how to find the mean by using this method, direct method. In this method, in the first row, we will see what are the columns. The first column is the class intervals. Second column will be the values of fi. The third column, we have to find out the values of xi. The fourth column, we have to find the values of fi xi, fi into xi. So now, the last column, we'll see what will be in the last column. In the last row, in this column, we'll have all the values of fi. We have to find the value of sigma fi. Sigma fi means you have to add all the values of fi and find the value of sigma fi. In this column, we have to find the value of xi. What is xi? Xi is the class mark. Xi is the class mark. We have to find the class marks of all the classes and write them in this column. Next, we have to find fi xi. We have to multiply fi into xi and find all the values of fi xi. Then in the last row, we have to find the value of sigma fi xi. Sigma fi xi. We have to add all the values of fi xi and find the value of sigma fi xi. Then, now the formula to find the value, the mean. So mean, the symbol for the mean is x bar. That's equal to sigma fi xi, sigma fi xi by sigma fi. You have to divide the value of sigma fi by sigma fi. We will get the mean. Now you will see how to find the mean by using the second method, assumed mean method. So in this case, the first row will contain what columns we'll see. First column is class intervals. The second column is fi's. All the fi's will be in this column. Next, you have to find out the value of xi. Then this is di. Di is equal to x minus a xi minus a. Then we have to find out the value of Fi di. Fi into di. Now in the last row, this is the last row. In this last row, you have to find the value of sigma Fi. Then you have to find the value of sigma Fi di. Here, what is A? You'll see, A is, you have to assume one value from xi. So, A is the assumed mean. Assumed mean. Among the values of xi, we have to assume one value. That value will be A. Then you have to calculate di. Di is equal to xi minus A. Then we have to multiply Fi into di. Fi into di. Then you have to add all the Fi di's and find the value of sigma Fi di. Now coming to the formula. What is xi? Xi is class mark. Xi is class mark. Xi is the class mark. A is the assumed mean. Assumed mean. Then now the formula mean, the symbol of mean is equal to A plus sigma Fi di by sigma Fi. A plus, this is the formula, A plus sigma Fi di by sigma Fi. Next we'll see how to find the mean by using the step deviation method. In this method, we'll see the different columns in the first row. The first column is Ci's, class intervals column it is. Next Fi's. Next you have to find out the values of xi's. Then you have to find the value of di. So di is equal to xi minus a. Xi minus a. Xi minus a. Then the next column is, we have to find the value of ui. Ui is equal to di by h. The last column is fi ui. Fi into ui. In the last row, we have to find the value of sigma Fi. Then now we'll see what is h. For all the values of di, you have to find the common factor. That common factor is h. So xi is a class mark. A is the assumed mean. H is the common factor. Among the values of di, values of di. Among the di's, the common factor is h. To find ui, you have to divide di by h. Then in this column, you have to find sigma fi ui. You have to add all the values of fi ui and find sigma fi ui. Now the formula. Mean will be equal to a plus sigma fi ui by sigma fi into h. This is a formula to find the mean. First sum. A survey was conducted by a group of students in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house. Which method did you use and why? They are given the data here. The data is 0 to 2 plants were found in one of the houses. 2 to 4 plants were found in 2 houses. 4 to 6 plants were found in one house. 6 to 8 plants were found in 5 houses. 8 to 10 plants were found in 6 houses. 10 to 12 plants were found in 2 houses and 12 to 14 plants were found in 3 houses. You have to find out the mean number of plants per house, and we have to tell them which method we have used and why we have used that method. Now we will solve the sum now. This is the data given to us. Now we have to find out first sigma fi. Sigma fi means adding all the values of fi's. We have to write it here. The sigma fi is 20. By adding all these values, we'll get 20. That's the first step. Second step, you have to find out the value of xi. What is xi? Xi is the class mark. To find a class mark, we have to lower limit plus upper limit divided by 2. See 0 plus 2 divided by 2. How much will get? 2 by 2. 1. The class mark is 1. Same way, 2 plus 4 divided by 2. 6 by 2. 3. The class mark is 3. Same way, 4 plus 6 divided by 2. 10 by 2, that is 5. The class mark is 5. Now we can write the remaining ones based on this. Here will be 7, 9, 11, 13. We have found the values of xi. Now we have to find the values of fi xi. Fi into xi. 1 ones are 1, 2 threes are 6, 1 into 5, 1 fives are 5, 5 sevens are 35, 6 nines are 54, 2 11s are 22, 3 13s are 39. We have found the fi xi. Now we have to find out sigma fi xi. Sigma fi xi. You have to add all these values to get the value of sigma xi, fi xi. It is 162. Now we'll find the mean. Mean equal to sigma fi xi by sigma fi. Here it is 162 divided by 20. That is 8.1. So the mean number of plants per house is 8.1. Therefore, the mean number of plants per house is 8.1. Please like, share and subscribe.